Okay, so hello guys. I am going to be talking about logarithmic expressions. Specifically, I'm going to be talking about some properties that are very important when it comes to talking about logs and to expanding or condensing logs. Especially when they look very complex, you want to start expanding it to make it look more simple and easier to solve. And if it seems like it's too long, that's when you want to condense it and you want to reduce the amount of things so that you can make it easier to solve. So that's pretty much what this is. So our essential question, what we're going to be asking here, very simple. It's how do you apply the properties of logarithms to condense and expand logarithmic expressions? So you can use the properties that I will be giving you to expand and to condense logarithmic expressions. I think that's a very important concept, and hopefully, um, you will try your best to remember this, and because it's going to be important for SAT, ACT, those standardized national tests. Those are it's very important that you know these sort of things because this will be on it, and it can make it a lot easier to answer logarithmic problems. So, I'm just going to read this out. Because of the relationship between logarithms and exponents, also known as logs. So basically what that's saying is the relationship between logs and exponents. They're literally inverses of each other. Exponents inverse is logs, logs inverse is exponents. So that's how you look at them. And if you've seen my other video, I think I show you how to rewrite logs into exponents and how to write exponents into log. Very simple procedure, the left, right, and middle procedure. But that's in a completely different video. But that pretty much explained that logs can be converted into exponents and exponents can be converted into logs. Due to that, so because of the relationship between logs and exponents, the properties of exponents have corresponding properties involving logarithms. So that's pretty much saying that your properties of exponents, they're also corresponding properties involving logs. So basically the same thing you'd think of in exponents you can see in log, and I'll give you the examples of what I have here. So we have the basically we're just going to be looking at our standard variables when we're looking at logs. We got let b, m, and n be positive numbers because you obviously cannot have negative numbers when we were talking about logs. That would make it undefined, and positive numbers such that b is never 1. It can never be 1 because that's a whole nother special property which also I'll be talking about in this video. But first let's go with our standard properties that you probably be able to recognize, especially from doing exponents. So we have the product property here. Product property, very simple, right here, right at the top, your product property. So basically what it says is log b. B is going to be your base for the log, so it's going to be that small subscript that's going to be on the bottom for your log, and log b mn. That's your combined thing. That's how it would be condensed. When you expand that, it equals log b. So it'll be log b m, m being your like number and b being your base, plus log b n. So that's very similar to your exponent properties, as you'd probably know. When you're pretty much multiplying two things with the same base, you have like 2 to the third power plus 2 to another power. You'd still add those up at times. It's pretty much the same thing here. You have log bm plus log bn, log bmn. You just have those two multiplied in one single log. And it's very important. These properties have to have the same base. Always look for same base when you're using these properties. That's very important. So, next thing, quotient property. So quotient property, standard quotient is your dividing. So log b m over n, similar to a exponent property. So basically what you do is log bm. So basically what you have is log bm minus log bn.